Alright, this is number 48 in chapter 5. So you're told you're going around a bank curve. You got the radius of 170 meters and your velocity is 25 meters per second. You're trying to find the coefficient for the static friction for the minimum to prevent you from sliding. So I've drawn this out. This doesn't really help too much right now. So let's draw the free body diagram of your car. So you have your weight, your normal force, and then in this example you're going around a curve. So say you're going to turn, you'll have your static friction in this direction. So say you want to turn right, you start turning, you're pushing off that way, or sorry, you'll be pushing off, I guess it doesn't matter, you're just pushing off of the pavement, and friction is going to push you in a certain direction. So one thing we need to understand is the centripetal force, or sorry, centripetal acceleration, which is this equation right here. So centripetal acceleration is velocity squared over the radius. So to find the acceleration, we plug in the numbers that we have. So the 25 squared over the 170 meters in the radius, and we get 3.68 meters per second squared. Now we know that the force of friction is equal to, let's see if I can remember this off the top of my head. That's supposed to be normal force. So static friction is equal to this constant times the normal force. So we can say that this is also equal to ma, because force is equal to mass times acceleration. So we can rewrite this in a couple different ways. So we know that the normal force is just equal to the mass times gravity. So we can say this normal force, just mass times gravity, which equals ma. And then you can change out the acceleration, because we're using centripetal acceleration, to this. So you get alright, so now we can plug in the acceleration here, or sorry, we want to divide this across. So when you divide it across, your masses cancel out, so you get that coefficient for static friction equals v squared over r divided by gravity. So you just take this acceleration that you got before, plug it in there, and divide it by gravity, and your static coefficient is 0.376. Now you're given a scenario where you're on ice, and you're now only given 1/3 of the static friction. So what's the maximum speed you can take the curve safely? So this is B, this is A. So now you just do this, but you times it by 1/3 and solve for velocity. So 1/3 static times mg, which is equal to m times acceleration, which we solve for. It's just rewriting this equation. Now you rework it again. When you divide over from here, the masses are going to cancel out. And then you're going to multiply by the r. So you get 1/3 coefficient times gravity times r equals v squared. Square root both sides. And then plug in the numbers you have. So times 9.81 times 170 equals v. And after you plug that all in, you get 14.5 meters per second is the velocity that you can safely go around that turn.